Good day, grade 9s. How are you guys doing this afternoon? Welcome to this physical science lesson. We're going to be looking at expansion and contraction of matter. So this is going to be a quick lesson, a quick video, if I can say, because these materials, these concepts, I explained them in detail last year on how we know that we have matter and that matter is made up of particles. And we know that these particles expand when they are heated and they contract when they are cooled down. So by the end of this lesson, we must be able to describe the process of expansion in the three states of matter by going through this video and reading the PDF that I've sent you. You must be able to describe the process of compression. So there's expansion, then there's compression, and then also there is diffusion in the mix. So by the end of this lesson, we must know more than what we know now, because we have talked about this before, but we are going to gain more knowledge. Okay? So let's look at these objectives and just try to recall in your mind, if you remember, these concepts and how substances expand, how they contract, how they diffuse, the specifics of it, if you can, or if you can just recall a general idea about the topic. So just pause the video for a minute and look at the objectives and try to see if you can recall anything. Pause the video. Okay, so we know, I have not the definition, but the definition of the term expansion, the definition of the term contraction, to increase in size as a result of heating, and contraction being to decrease in size as a result of cooling. This is in relation to states of matter and to materials that we are used to seeing. We know that when you see a metal, when it's heated, it's going to start expanding, but then when it's cooled down, it's going to contract, right? Get smaller. To expand is to get bigger. To contract is effectively to get smaller. So there is an image here of the ball and ring apparatus, and it shows, there's also a video that I'm going to play just now on that is showing contraction and expansion in different substances. But you guys know the concept of how initially in a ball and ring apparatus, first you have a ball that can pass through a ring, and then that ball is heated and it expands, and then does it still pass through the ring or does it fail to pass through the ring? You then deduce from its ability to get through the ring or failure to pass through the ring, and then you can tell to say, oh, so this ball expanded or it contracted, right? We also have the bimetallic strip in the video. There's also in this video, not in another video, but in this video, I'm going to put a video on top of this frame, and you're going to see how a bimetallic strip actually works and helps with something called a thermostat. I hope you know what thermostats are. They're there in your irons. You know irons, when you're ironing, sometimes you see the light on the iron will go on, and then the heat will start increasing on the iron, but after a while, the light will go off. That's the thermostat saying that the temperature is now enough, otherwise you will burn the clothes. Then the iron goes off, it cools down a bit, you iron your iron. When it sees that, okay, the temperature is not enough to be ironing the clothes, again it goes on. It's a pretty simple but very effective concept. So what I'm going to do is I'm going to play the video that is explaining some of these concepts.
Bridge builders need to know that changing the temperature of a material changes its size. When solids get hotter, they expand. Here's a thick metal bar resting in a frame. Insert a cast iron pin through the hole at one end. Heat the bar for about 10 minutes. It expands and gets longer. Now tighten the nut to hold the bar in place as it cools. What will happen to the pin? As the bar cools, it contracts, it gets shorter. The increasing force on the pin eventually snaps it in two.
Okay, so I hope if you didn't really understand, you just rewind, it's rewinding, yes. You just go back a bit in the video, but effectively, because the iron is now cooling down, right? When it was heated, it expanded. It expanded, which means that it grew longer. But now, because it's being cooled down, there is this one which broke into two. It's not the metal that was being heated that broke into two. It's the pin that was now placed in to prevent it from moving, right? So now, as it is growing, as it is now contracting, it wants to go back to its original state, right? But this pin can no longer hold it in place, so it snaps. So it snaps in two.
Here's a metal ball and ring. At room temperature, the ball passes easily through the ring. Now cool the ring in liquid nitrogen.
Liquid nitrogen. So what's happened? What do you think has happened to the ring? Ask yourself, answer this question wherever it is you are right now. It has been placed in liquid nitrogen. Liquid nitrogen is extremely cold. It's extremely cold. So what do you think has happened to the size of the ring? Okay? You will be answered immediately when you see if the ball will pass through or not. So answer this question to yourself. Say, if it's been placed in an extremely cold substance, has the ring expanded or has it contracted? If it is expanded, the ball will just pass through. If it is contracted, the ball will not be able to pass through.
The cooled metal has contracted, so the ball no longer fits through the ring. Expansion of solids can cause problems. Railway tracks, for example, might buckle during hot weather, so expansion gaps or sliding joints are built into the trackwork. When heated, different metals expand by different amounts. Bonding a piece of brass to an equal piece of iron produces a candle is placed under a bimetallic strip. Can you work out what's happening? The bimetallic strip is working as a switch. Heat from the candle causes the strip to bend downwards.
Okay, so heat from the candle causes the metal strip to bend downwards. When it bends downwards, it completes the circuit. Remember, we talked about circuits, and the electricity can only flow when this circuit is complete. So when it's heated, the metallic strip moves down. It's a bimetallic strip. So it moves down, completes the circuit, and then the fan starts rotating. But when the fan starts rotating, it cools down the bimetallic strip and it rises up again and cuts off the circuit.
This completes the circuit supplying power to the motor. The fan then runs, cooling the strip, which bends upwards, breaking the circuit, and so on. This shows how bimetallic strips are used as switches in thermostats. Liquids expand more than solids. These flasks contain 3 different liquids: water coloured red, paraffin and methylated spirit coloured blue. Heat the flasks in a water bath and the liquids will expand. But will they all expand by the same amount? Methylated spirit on the right expands the most. A similar liquid is used in many lab thermometers. Why is it so suitable? Gases also expand when heated. This glass flask is full of cold air.
Right, so let's just go back here. This is now expansion in liquids. But you observe that the methylated spirit expanded more than the water. That is now something to do with density of the substance that is being used. You'll find that the density of the methylated spirit alcohol is the least dense. So substances also, depending on their density, will expand differently. will expand differently. That's why we say we have expansion in solids, expansion in liquids, and expansion in gases.
Heat the flasks in a water bath and the liquids will expand. But will they all expand by the same amount?
I hope the video is clear, but you can see that the methyl spirit has expanded the most because it's here where I'm touching. This is where the methyl spirit is. Then the second substance, what is the second substance? The first substance is water, but you can see that the water is expanded the least, right? Because of these three substances, it's the most dense.
Methylated spirit on the right expands the most. A similar liquid is used in many lab thermometers. Why is it so suitable? Gases also expand when heated. This glass flask is full of cold air. Using your hands, warm the flask, dipping the end of the tube into some water. Bubbles soon begin to appear as air inside the flask expands, forcing its way out of the flask and into the water. Cool the flask and the water rises up the tube as the air inside contracts.
Yeah. So guys, I hope you were able to see how expansion in liquids works, right? How expansion in liquids works and how expansion in gases also works. From the final video, because if you put your hands on the valve, this one, right? When the person puts their hands on the jar or the what's it called? It's like a round bottomed flask. It's called a round bottomed flask. When they put their hands there, they're going to heat it up. They're heating it up, so the gas that's inside the flask expands. That's why it's going out.
Water.
You can see the bubbles as it goes out, right? And then when you put a cold cloth on it, then it starts sucking in because now the gas inside the flask is now contracting, which means there's more space which can be occupied. Right. So you please look at also the concept of compressibility, right? Read up on the concept of compressibility. We will talk about this in the WhatsApp lesson. Diffusion. We know about diffusion, but I think what's also just important to mention is that now diffusion of substances will differ based on the size of the particles. So if a substance is heavier, right? If it's heavier, then its particles are going to diffuse more slowly. Right? I'll explain it in the lesson proper. Okay, so guys, thank you very much for watching this video. The notes, you have them. Just go through the material so that we can be able to discuss meaningfully. And yeah, thank you very much for watching.